Okay, so in this video, I'll be showing you how to solve systems of equations using the graphing method. And so basically, we're going to graph each of the two linear equations. We're going to get two lines. And then normally what happens is we have a point of intersection, and that point is our solution. But then we also have a couple of special cases that we discussed in the previous video where I introduced you to systems of equations. All right, so let's go ahead and get started here. Now when we graph lines, we have three different methods we can use. We can graph by plotting points. Normally we want to solve for y and then plug in some x values and solve for y. We usually find 3 points and we use those to draw the graph. We could also use two special points, the x and y intercepts. We call that the intercept method. And then finally, probably our go-to method is when we graph using the slope and the intercept, the y-intercept. So let's go ahead and get started. So we have x plus y equals -1. Let's go ahead and use the intercept method. Anytime you have an equation in this form, it's called standard form, where you have the x term, then the y term, and the constant term on the other side. The intercept method is one method to consider. And so here I'm going to go ahead and use that. So I'm going to choose x to be 0. And you can see if I put 0 in for x, you've got 0 plus y equals -1. And so y will equal -1. And similarly, if I plug in 0 for y, I would get x equals -1. So let's go ahead and plot those points. And now when you draw these lines, you want to draw them as straight as possible because you're looking for an intersection. And so sometimes what I'll do, you'll notice that from the left point to the one on the right, you're going down one, right one. So I could go down one, right one, and find another point here and here. You could do the same thing going in the other direction. And so that's one way you can draw yourself a straight line more easily. So here's our first line, x plus y equals -1. Or the graph. And now I look at the next equation, I have x minus y equals 3. Now I could use the intercepts again, but I want to show you the plotting points method, or finding 3 points. And in fact, it's pretty easy to find two numbers that you can subtract and you get 3. So I'm going to go ahead and use 3 and 0, because 3 minus 0 is 3. Or how about 4 and 1? 4 minus 1 is 3. Let's go ahead and plot those points. Now you can see we're kind of heading the wrong direction here. We want to find the intersection which is in the opposite direction. So let's choose x to be, how about 2? So if we have 2 minus some number, that would have to be -1. And so y would be -1. And you can see when we graph x minus y equals 3, we're going to have an intersection with the other line at 1, -2. Now, again, we want to be as accurate as and draw things as carefully as we can so we can find the correct intersection. But remember, we can always plug in the point 1, -2 into both equations, and it should work and make each equation true if you wanted to make sure that you had the right point. All right, so our solution here is 1, -2. Because we have at least one solution, this is a consistent system. And finally, it's not the case where the two lines are the same line. That would be the dependent case. We're going to be independent. And so this is our most common case. We're going to get a point of intersection. That's going to be our solution, which means we're consistent and our system's consistent and also independent. All right, let's move on to number 3. Well, we've already used two of the techniques. Let's go ahead and use the slope-intercept method next. Now, just as a way of review, if you write y equals mx plus b, this is slope-intercept form. Remember, m's represents slope, and the b tells us where the y-intercept. It's going to be at the point 0, comma, whatever that number is, 0, comma b in general. So on the first equation, we have 2x minus y equals 7. So I'm going to go ahead and solve for y here. So I'll subtract 2x on both sides. We get minus y is equal to minus 2x plus 7. And I can either multiply or divide both sides by -1. And when I do that, all my signs are going to change. So I'll get y equals 2x minus 7. So my y-intercept is going to be at 0, -7. And my slope, well, let's go ahead and plot that point, 0, -7. Our slope is going to be 2, which we want to write as 2 over 1. Remember, slope is, we can think of it as rise over run. So starting at the point 0, -7, we're going to rise 2. Since it's positive, we're going up 2. And then we're going to go 1 or run 1, which means we're going in the positive x direction. So 1 to the right, and that puts us at this point here. Now I could do the same repeatedly, so I can draw myself a nice straight line. I'll go up 2, right 1, up 2, right 1, and I'll go one more time, and you can see our line there for 2x minus y equals 7. All right, let's go ahead and do the same thing with the second line. We've got -2x plus 2y equals -6. Let's go ahead and add 2x to both sides. We get 2y is equal to 2x minus 6. And let's go ahead and divide by 2. And so we'll end up with y equals, now 2x over 2, that's going to be 1x or just x. And a minus 6 over 2, that'll be minus 3. So our y-intercept is going to be at -3, 0, -3. And our slope here is 1, which notice I'm writing it as 1 over 1 because I need to have a rise and a run. So I'm going to go up 1 and right 1, and that gets me here. And I'll do that a few more times. Up 1, right 1, up 1, right 1. And you can see once we graph that line, we're going to intersect at that point 4, 1. And so that's going to be the solution to our equation, or a system of equations. So our solution is 4, 1. We have at least one solution, so this is a consistent system, and this would also be an independent system. All right, let's move on to the next slide. Now I would encourage you to go ahead and see if you can do these two problems. Go ahead and stop the video and then watch the video and see how you did. All right, so here on number 4, we have f of x equals 3/2 x plus 1, and g of x equals -1/4 x minus 6. Now, the only thing that's different here, other than these are going to be pretty easy because they're already in slope-intercept form, is we have function notation instead of the y notation. So just think of f of x and g of x as another name for y. So let's go ahead and graph these. So for the first equation, we'll start at 0, 1, our y-intercept. We're going to rise 3 and run 2, and that puts us here. Now I could go up 3 again and right 2, but I'd kind of like to go in the opposite direction. So notice if I started at the point on the right, I could actually go, whoops, hold on a sec. I could go down 1, 2, 3, and left 2 to get to that point. Notice -3 over -2, that's still 3/2. So let's go ahead and do that. We're going to go from this point here, we're going to go down 3 and left 2. And so there's another point on the graph. And in fact, I'm going to go down 3, left 2 again. And so here's my line. That's the graph of f. Now for g, we're going to start at -6. And now -1/4, when we write it as a fraction, we could write it as -1/4, or we can write it as 1 over -4. The main thing is that you don't apply the negative to the numerator and denominator. A negative divided by a negative would be positive. That's not what we have here. Now I usually go with the negative 1 over 4. I put my negative in the numerator, but it really doesn't matter. I just try to be consistent in that regard. So let's go ahead and go down 1 and right 4, and that puts us here. Now notice that did take us away from the line, so maybe I should try going the other way. I'm going to use 1 over negative 4 starting at the same point at our y-intercept. So I want to go up 1 and left 4. And so here's our line, that's G, and you can see our point of intersection is the point negative 4, negative 5, and so that's going to be our solution. Since we have a point, or at least one solution, we have a consistent system, and again, this is not the dependent case. That would be if we get the two lines are actually the same. This is not that situation, so this is an independent system. All right, let's move on to number 5. So the first equation here, you have y equals negative 2, and the second is x equals 3. Now keep in mind, these are what we call the special cases. There's only an x or a y in each of these, and it turns out these are vertical and horizontal lines. So y equals negative 2, well, that's true here, and we want to draw the horizontal line through that point, and so that's the graph of y equals negative 2. Now sometimes students get their line going the wrong direction. If you wanted to, you could make a table and pick y to be negative 2 3 times, because it doesn't matter what x is, but y has to be negative 2, and you could let x be whatever you want. I usually choose 0, 1, and 2, and you can check those 3 points are on this graph, and so that may help. Now x equals 3, that's going to be a vertical line going through this point here at x equal to 3. In fact, all of these points on this line are 3 to the right. That's because x is equal to 3. We're going 3 to the right. Every point, in fact, every point on this line has an x value of 3. All right, so the other way to see it again is to draw a table of values like I did previously and let x be 3 each time. And again, I'll choose y to be 0, 1, and 2. And you can check to see that those points are on my line here for x equals 3. So our solution is that point of intersection, 3, negative 2. And so that's our solution here. This is also a consistent system and an independent system. All right, let's move on to the last page here. So again, I would encourage you to go ahead and at least start these. You could graph the lines anyway, and then see if you can determine what your solution would be. All right, so let's see how you did. So on number 6, I think for the first one here, I want to go ahead and make a table of values. Notice that 3 and 3, the coefficients of x and y, divide evenly into the constant here, negative 6. This is a perfect setup for finding the intercepts. So let's go ahead and let x be 0. And so let's plug in 0 for x. We get 3 times 0 plus 3y equals negative 6. And of course, 3 times 0 is just 0. This just zeroes out. And you're left with 3y equals negative 6. And you can see y would be negative 2 there. If I choose y to be 0, we can do the same thing, and you get negative 2 for x. And so let's go ahead and plot those points and plot that line, and or I should say graph that line. And now let's go to the other one. Now we have y equals minus x plus 4. And so this is in slope-intercept form. So let's start at the y-intercept, 0, 4. Our slope here is going to be negative 1, which we can write as negative 1 over 1. And so we're going to go down 1, right 1. And we can do that a few times. And so here's that line. And so these are parallel lines. So if you think back to what we discussed previously in the previous video where I introduced you to systems, we learned that with parallel lines, we have no solution. basically there's no point of intersection, and so there is no solution to this system, and so we would say no solution. Because there isn't a solution, we would say it's an inconsistent system. Now notice these aren't the same lines, so we're still independent. All right, so now I want to go ahead and I'm going to actually solve for y for the first equation. So I'm going to subtract 3x from each side, and then I'm going to divide by 3, and you get y equals minus x minus 2. And you can see that our slopes, are the same. And so that is a value to using the slope-intercept method, is you can easily tell if you're going to have parallel lines. All right, let's move on to the last problem here, number 7. So in the first equation we have 2x plus 3y equals 6. In the second one we have 4x plus 6y equals 12. So I'm going to go ahead and again use the intercept method. So when I let x be 0, I'm going to have 2 times 0 plus 3y equals 6. Again, 2 times 0 is 0. This zeroes out, and you're left with 3y equals 6, and that means y would be 2. Similarly, if I let y be 0, so just put a 0 in here, you would get x equals 3. And so let's go ahead and plot that line or graph that line. Now if I do a table of values for the second equation, let's go ahead and let x be 0. Let's plug 0 in for x. 4 times 0 is going to be 0. You're left with 6y equals 12, and that means y is 2. Similarly, if I let y be 0, so plug 0 in for y here, you would get 3 for x. And when you go to plot that, you realize that's the same exact chart that we had for the first graph, or the first equation. So these two equations are equivalent. They represent the same line. In fact, if you on the second equation, if you divided both sides by 2, you'd have the same equation as the first one. And so here our solution is going to be that we have infinitely many solutions. We graph the two lines. What do they have in common? Everything on the line. So we have infinitely many points on the line, so there's infinitely many solutions. This is going to be a consistent system because we have at least one solution. And this is the dependent case. So this is a dependent system. Now one last thing here. We just wrote our answer as infinitely many solutions, but if you think about it, this is kind of a lame solution here, or an answer here that's kind of lame, because I'm saying there's infinitely many solutions, but I haven't even told you even one. And so there is another way, depending on the book you're using, you may or may not have to do this, but usually we do it in college algebra. So what I'm going to do is I'm going to take the first equation and I'm going to solve for y. So we'll subtract 2x on both sides. We get 3y is equal to negative 2x plus 6. Let's go ahead and divide everything by 3. We get y equals negative 2/3 x plus 2. Now, notice what we have here. We have y in terms of x. So if I told you what x was, you could tell me what y is. And so we can actually write a point in general for all the solutions. So the first value is going to be x. So basically we're saying let x be anything. The y value in terms of x would be negative 2/3 x plus 2. And so this is how we would actually write, or it's a way to write all the solutions. Now it's not the only way. We could have solved for we could have solved for x and kind of done the opposite thing. We would have had y here and some expression in terms of y here. All right, but we're just going to do it this one way here for now. So for example, if you were to let x be 0, then you would plug 0 in here. Negative 2/3 times 0 is 0, and 0 plus 2 is 2. And so 0, 2 is one of our infinitely many solutions. And you can find other points just by picking other values for x and plugging that value in to figure out what the corresponding y value would be. All right, so that's it for this video.